Hi, hello, how's everyone doing? I'm assuming everyone else already did their challenge. I finished yesterday's challenge upstream very late at night actually, because I had too much work to do. That's why there's no blog post yesterday either. Yes, so what I'm going to start to do is I'm going to start parsing the files before the stream so that we don't spend an hour doing it during the stream. And so this is what I came up with. So a file defines a program, right? And a program is just a list of instructions and an argument. I haven't actually tested this. Let me see. Let me see. Shit. Inline wrap. Day 8. So we want to check that parse file works, right? So let's take those two lines. Whoops. Parse file, right? Of this. It doesn't like the return line. Parse file. Does it? First of all, does it recognize this? Yes. Parse. Okay. So parse file works. So \n ACK +1. This is really slow. Why is it struggling so much? Is it just REPL things? Is it just REPL things that it's so slow? Okay, let's take this input and do vim est input 8. Exec. That's right. I forgot about this. Load day 8 exec print. What was it? Parse file? Parse file of no. And \n ACK +1. Cannot find implementation for show maybe instruction. Show instruction where show of ACK is ACK nop is nop and jump is jump. Does this work? Oops. Fantastic, it does work. Does it also work with negative numbers? Yeah. Cool. So parsing is done. So now we need to execute this program, right? Cool. So what we want to do is, given a program, we want to find the value of the accumulator after it visits an instruction that it has already visited, right? So what we are going to do is we need a way to execute programs, right? But they won't be infinite. What we are going to do wait. We need to execute a step of a program, right? I'm gonna do the other one. So I'm gonna do the other part. The other part is immediately before the program would run an instruction a second time, return the value in the accumulator. Right? So we have how to call this? So we have a program, right? And in addition to the program, we have a history of instructions, right? So let's call this list of nuts, right? And this is the history. One way to do this is doing this. I'm tempted to do the following, and that is, say program is a vector of n instructions, right? And this is a list of bin n, right? And then we can index on it. Yeah, actually I'm gonna do that. I'm gonna save this parsing for now. We're gonna save it for later. Well, actually, traverse parse instruction, right? This would work, right? Import data.vect. Let's see, 20. Two vects. There must be a way to transform between list and vectors with a extension, right? Vect. Length, head, lasts, delete, replace, update, replicate, merge, intersperse, from list. That's annoying. Is there no like from list with the dependent pair? Oh my god, are you kidding me? From list. Just... Oh, I see. Yes, yes, yes. Yeah. Let me think about how to do this elegantly. I don't think there's a nice way to do it, right? You have to do this, right? Cool. Okay, that works, that works. So given a program and a history, we want to return a net, right? And we're also given a function pointer, right? Or instruction pointer. So this is also a fin n, right? Cool. So given a program and a instruction pointer, and a history, we also need the current state, right? So the current state is an int, isn't it? Current state of the accumulator. So if the instruction jumps to an instruction that is already in history, then we return the current state. Otherwise, we keep going, right? And this is going to be partial because it can go forever technically. Cool. So what we need to do is we need to next is we need to get the next function pointer, right? Next pointer from and this needs to be instruction and program. And if this is empty, then we'll return state. Right, so we return the next, we need to get access to the next pointer, right? Next pointer takes instruction and this might fail also, right? There's so much state. We should be using state right now. Oh, there's so much state. Should we just use state? With like the three states we're looking at is current function pointer, current history, current state. Don't get corrupt with state. Okay. Program state, right? Program state. I'm just gonna write this like that, right? Program state is fin n, right? Int and list of fin n, right? Right, and that's just program state. Right, and now we can just use this. I haven't been corrupt yet. I'm just making it cleaner, right? Did you solve it without state? Okay, so I'm gonna make a comment. So the states of the execution is a triple of the current function pointer, the current accumulator value, the history of instructions executed. Cool. So in order to get the next function pointer, dependent records, I guess that's what it is. It's index records, yeah. In order to get the next function pointer, we need to just avoid the hell of... good idea. Okay, I'm gonna do it later. So for now, I'm gonna focus on how to get the next pointer, right? So in order to get the next function pointer, we need, and this is just. So this needs to be a do notation, right? Next pointer returns maybe bin of n, right? And it takes program of n, and it takes an instruction, and it takes I don't like this argument order. There we go. So first the instruction and then the program. And returns maybe an index, right? Because if it's out of bounds, then it's nothing, right? Then, so this is the next pointer. So if it's out of bound, we just return nothing. Now, if Next is an lm of hist. Then your state. Else recursive call with oh, that's tricky. We also need so many things. Oh my god. This doesn't make sense, right? This doesn't make sense. We also need the current instruction we're looking at, right? The current instruction not yet executed. Right? Oh, never mind. This is already fin n. Okay, wait. Yes, so let's instruction is index IP prog, right? Instruction. Why is it unhappy? Mismatch between instruction int and instruction. Because the instruction does not have its argument within it. Oh, I'm just gonna do this. Yeah. And when parsing, I'm just going to do this. Does that compile? So it doesn't compile because of this, but we can solve this. We need to ignore the argument for now, and this returns the wrong kind of arguments. Fantastic. Cool, cool, cool. So prog stays the same. IP is next. State is, we need to update the state. So state is execute. Execute instruction given a state. And history, and we append instruction to history. Right, does that make sense? We'll recursively execute the thing. So I'm gonna call Juno interpret. So in order to interpret our program, given a program state, we'll look at the next instruction. We compute the next instruction pointer. If we find that the next instruction pointer is somewhere illegal, we return the state. Otherwise, we keep going. I think this is slightly wrong though. I feel like this is slightly wrong. I think this should be in here, right? If the instruction we are looking at, yes, this is more correct. If the instruction we are looking at, this is just after we finish jumping. Cool, cool, cool. If the instruction we're looking at is already in history, return the previous state. This makes sense. Execute is simply given an instruction and an end. We return a new int, right? Does it compile? Instruction. Mismatch between instruction and... this is IP. Yes. Yes, and this is not instruction, this is IP. Cool. So this is ACK. It's N3, isn't it? What is... So this is just ACK. And this is just ACK. Given a program N, how do I get the next instruction? I think I need to get access to N, right? I've been writing way too much Haskell. I almost wrote double colon by reflex. So this is +1, this is safe +1, this is safe +1, and this is safe add. Let me look at the fin. Let me look at the fin library. You can add them safely, right? Net fin, last shift, strengthen, weaken. I guess I want to do FS and then strengthen, right? Is there no add? Or do I just have to go like to net and then do nets to fin? Or is net to fin? This is fin to net. Fin to int. Add some natural bounds to... Huh. Fins are much harder to work with than I expected. Like, I expected to have something like this. Right, and safe add is fin n nat to maybe fin n. I guess I could just write it, right? We don't need the program anymore. This fin n, there we go. Yes, and this is int. Cool, and here IP is the bound, but we actually need wait, where is it? Next pointer, yeah, this is IP. This is IP and this is instruction. There we go. Cool, and safe add does the thing, right? So how do we do safe add? I think we turn the fin into an int. Then we do the operation. And then we do integer to fin, yes. So So this is integer, oops, integer to fin. Mismatch between this and that. Ah. We still need bound though. I guess that's okay. I guess we always needed the bound. And is not available in that context. There we go. Where is fin to integer? Here. This is plus y. Oh my god, why does it hate ints? I'm just gonna use integer everywhere. No, why does it hate ints? I can just use cast. Oh no, I can't. I can use cast twice. Cursed code. Cursed code. Two is int, right? Mismatch an int and integer. Ah, integer to fin doesn't work. I see. So this needs to be. I see. Wait. No. This is wrong. This is wrong. Integer to fin is integer? Oh my god, it's integer. Okay. So I also have to cast this. That's... yeah, that's pretty cursed. It's pretty cursed, but it works. Okay. Okay, so this is given an instruction and a state. Get the new state. It's done, so it won't get any more cursed than it already is. Given a current function, current instruction pointer, and an instruction, get the new instruction pointer, and this is safely add to nats. Safely add an int to a fin n. Safely, yes, notwithstanding the maybe. Cool. So let's try it out. Quit interest 2 day 8. Oh, there's a hole. Where's the hole? Here. The program. So what type is our parsed? Parsed is this vector. Is this thing? Yes. Whoops. I need to do show of interpret of. So this is n and parsed of parsed program state 0, and that's it, right? Does this compile? This does not compile. Cannot find implementation for fin n and stuff. Yes. program state is this. So we need to give 0, 0 an empty list. So this is 0, 0 an empty list. Let's try again. Can't find implementation for is just integer to bin. 0. Are you kidding me? There we go. Compile. So do we have a test input? I think we have a test input. Tests input 8. Act after repetition is 5. Cool. So let's get the puzzle input. Save link as. Put 8. I really love that Idris almost doesn't have any bugging like to do. Like once the thing works, it just works. Does it work first try? Yay, first try, easy.